Hello everyone, welcome to another solution video. On this one, we're going to be working towards our data variable worksheet together. Before I begin, I just want to explain my setup here. So up here, I have my code editor. So whenever I want to show you an example of a multi-line code, I'm going to edit them here to click run, and it's going to be ran on the interpreter. At the bottom, I have my interpreter here. So if I were to test single line code and show you how the interpreter works, I'm going to be testing my single line codes there. Right. So here we go. Let's talk about the major data types. There are three major data types in Python programming: numbers, letters, and data sets. For numbers, we mainly deal with integers and floating points. The only difference is that integers they don't have decimals, whereas floating points, they do have decimals. So floating points can get more granular and more specific with our numbers, whereas our integers, we're really dealing with positive and negative whole numbers. In terms of letters, they're called strings. They can be alphanumeric or special symbols. Even a white space is part of a string, and anytime we use double quotation mark or single quotation mark, you are looking at a string. Lastly, if you wanted a collection of multiple different data types or create a sequence of numbers or letters and stuff, you can, or multiple words, I should say. We are creating something called an array in programming, and in Python, we call them a list. We use a square bracket to start off a list. So in this example here, I've listed fruits. Each fruit is a string value, and there are 3 string values inside this list. So I have a data set of fruits. In the second example, I have numbers 1, 2, 3, 4, 5, integers of 1, 2, 3, 4, 5, and they're trapped in square brackets. So that's a list of numbers. Both a list and a string can be empty. If we have no values in them, there's something called either an empty string or an empty list. There's still a data type of a string or a list. We just haven't put any values inside them. So continuing on with data types, exercise 1, I've given you these values and I'll ask you to determine the data type of each value. And to help you with this, I'm just going to show you a little cool function called type, which we talked about in our previous video. So if I wanted to type of what the value 42 is, it will output a class of integer. So the word class is something you don't need to worry about. That is related to a programming topic called object-oriented programming. And so if you want to read up on more on that, you can Google that later. That is something that we cover in grade 12 because we learn how to do object-oriented programming in grade 12. Right now, in this section of the course, you are working on towards procedural programming. And so we don't need to worry about the idea of a class. However, we do need to worry about data types. So as you can see, if I use the built-in function called type and give it a parameter of any value or variable that has value, it will determine what that type was or what data type it was. So in the first row, we have integers. On the first 3 items of our second row, we have floating points because as you can see, they have decimal values. I didn't put any negative decimal values here, but floating points can also be negative. Our next 5 examples are string values because they are trapped with a double quotation mark. String values can also be trapped with a single quotation mark. That is based on your preference. I actually prefer single quotation, but just for this exercise set, I kept it as double quotation set. A string of 3.14 is very interesting because as a non-programmer, when I look at that, I look at it as a number. That is a decimal. However, there are double quotations trapping it. Therefore, ultimately, the data type of this data is 3.14. Next, our list can have just a single value. It's usually called a singleton if we were to give it a name, but it has also square brackets, so it's a list. It's a singleton list. There's only a single item in that list. Our list can be empty. There's nothing in between the square brackets. There are no commas separating multiple values. There is not even a single value in that list. So that's an empty list and it's still data type list. So if we were to test that with our type function, we get a list. Next, we have 2 strings in our list, so that's still a list. And we have the first 5 prime numbers in our list, and that's still a list. There's one data type that I haven't talked about in this worksheet because it is a future unit, and it deals with the idea of Boolean. Boolean are used for conditions or decision-making situation. So for example, if I had a program that determined, is it raining today? It can be either true, that statement being true, or it can be false, and that is a condition. And there's a whole unit called conditionals that we'll be working towards. And some of you might be wondering, well, why is it called Booleans? It is called Booleans because it was named after George Boole, a famous mathematician programmer who invented the idea of something called Boolean logic or Boolean algebra, I believe. I don't know if he invented, but he is definitely a big part of that. So we denoted true false value with his last name. So moving on, we talked about data values. We need to store them in variables in a container so that we can manipulate it or refer to it whenever we need. Just like we talked about before, a variable consists of 3 parts. A label to the left of the assignment operator, which is our equal sign, and a value. So in this example here, I have a variable that is labeled with age. We don't need any quotation marks here to denote that as a variable name. We just write it as it is, no quotation mark. So I have a variable named age. I'm setting it with the value. To do that, we use an equal sign. In mathematics, an equal sign is denote that left side is equal to the right side, as in it is balanced and each side is equal to each other. However, in programming, a single equal sign means that this variable to the left is containing the value to the right. And in this case, we gave it an integer data value of 26. And these are some examples of floats, strings, or a list that has different variables. So connected to that, on exercise 2, I gave you 5 prompts. And I asked you to create variables with proper values for them. Now, your answers may vary because it depends on how you understood the problem. But here, I'm going to actually try some of these out. So I have a variable called full name. I'm clearing my interpreter. I'm going to set it to Mr.Park. So if I run this code, nothing has happened, but I promise you our program has worked perfectly. In line 1, 2, I have a comment, so our interpreter is going to ignore that. On line 3, there's no code, so it ignores that. On line 4, we have now created a variable called full name, and it's set to a value of Mr. Park. So if I were to say print, I want to output something to the interpreter, and what I want to output is the value of our variable full name. And we get Mr. Park as our output. So what is happening? Interpreter ignores line 1, 2, 3. Line 4 created a variable called full name. And line 5, the print function takes a single input parameter. And it was a variable that we created before. I can't run this code if that full name variable hasn't been created before that. So on line 5, it calls up full name and it asks, what is your value? I want to use it for my function. Then it prints that value. Therefore, on the interpreter, we get Mr. Park. Let's move on with the rest of our exercise 2 solution. So birthday, you could have held it in a single string, January 1st, 2000, or you could have said, hey, birthday is contained in a list with the month being first. We have integer values for our date and the year that you were born. Our birth year, I just kept it simple. I'm following a camel casing naming convention, and I'm set it to an integer value of 2000. This sounded like a condition. Are you breathing? So I'm using now a underscore naming convention is underscore breathing and set that to a Boolean value of true because that is a condition variable. For a list of TV shows, I'm pretty sure everyone has different tastes. Right now, my favorite shows are Brooklyn Nine-Nine, Friends and Community. Therefore, I set variable shows is equal to a list of these 3 string items. Moving on, let's talk about mathematical operations. So there are 1, 2, 3, 4, 5, 6, 7 operators we can use in Python, plus, subtract, divide, multiply, modulus, which is a remainder finder, which we'll talk about later. And if you wanted to exponentiate a number, we have the double asterisk symbol. And also we have floor divide if we wanted to round down every time we did a division to the nearest integer. Cool thing about these operators is that I can use that with variables. So if I wanted to do some multi-line programming here, I can do first is equal to 12, second is equal to 13, and say that, hey, result is equal to the result of first plus second. And let's print that result. We should be expecting 25 here. And I print 25. In line 4.5, I have initialized two variables called first and second with respective values of 12 and 13. In line 6, I created a variable called result, which is the result of first added by second. And we could have used any operator here out of the 7 we just learned, but I decided to use the addition. Let's talk about the modulus and the floor division operators. Modulus is a remainder finder, and sometimes in different textbooks, they'll call it a modulo. So when we divide 5 by 2, we get 2.5. So we have that 0.5 left over. But let's say we're strictly doing integer divisions, we don't want to look at a decimal value. So if I were to do 5 floor divide by 2, I would get a single value of 2, and it would just forget about the 0.5. But if I still wanted to know what that 0.5 was, I can do 5 modulus 2, which would give me a value of 1. As in, I have 1 out of 2 left over. So that's why there's the 0.5 here. And that would be the integer equivalent of what's 0.5 left over would be when we're doing a division of 2. In exercise 3, these are the following results. So if I did 14 modulus of 10, I'll get 4 because only one 10 goes into 14. So 14 minus 10, we have 4 left over. In this scenario, 7 4s go into 29. So 29 minus 7 times 4 is 28. So we get 1 left over. So C is 1. In this scenario here, I flipped it around. I'm looking at how many 2s goes into 43. There are 21 2s that goes into 43, and I'll have 1 left over. In this final example, we're going to program that together on the interpreter because we can do single line programming there. I can do 11 divided by floor divided by 2 for A. B is set to 11's normal division by 2. And then C is equal to order operations here. All in brackets of A plus B, all divided by floor divided by 1. Awesome. I'm going to print A to show you what that was. Well, 11 floor divided by 2 was 5. Print B. We get 5.5 because if I just did normal division, we're still allowed to keep the decimal in an improper division. Then we do print C. We get 10.0. And this is something I wanted to show you. The reason is that when we do work or mathematical operations with numbers, floating point takes priority in Python. So we started off with working with integers, but variable B ended up creating a floating point. So A plus B ended up becoming 10.5, which is a floating point value. Even if we did a floor divide by 1, this will not reduce it to 10. Rather, it will maintain the integrity of a floating point and leave it as 10.0, even though it was still a perfect division at that point. Okay, we're going to talk about the very last item on this worksheet, which is the IPO model. We'll do a deeper dive into the IPO model later, but what an IPO model stands for is I is the input, P is the processing, and O is the output. Basically, we follow this structure when we design a solution to a problem. A lot of new programmers love to just start coding right away and think about the solution top down. But I do recommend that whenever you look at a problem from now on, that you look at and analyze what are the requirements to solve your problem. What are the values that I need? Do I have any inputs? If I grab those data from my input, how do I process that? What is the algorithm I need to follow to solve a given problem? And then at the very end, what are my expected outputs? So in our programming example here, I had my values of first and second as 12 and 13. It is expected that I should get 25 if I were to add them. So if by knowing the expected output, we're able to design a clear instruction set for our code. So when you have a design, when you have an IPO model made and thought out, it is very easy to translate that over into programs. And on that note, let's talk about an example algorithm. To the left, I have the 7 lines of code, which I'm going to copy over to my code editor. Num1 is equal to integer input. If you notice inside my input function, I don't have anything inside. And I'm just going to copy those over. And I have a variable called result, which is the num1 plus num2 all floor divided by num3. And we're going to print the result. So in this section, that's their input section. This program, this algorithm required 3 inputs. Therefore, we had 3 variables. See, if we were to map how many inputs we need, we get to determine how many variables we need for those. And we're grabbing integer values. Our processing section was held in a variable called result. And if we were to add up num1 and num2 and divide it by num3, that was our processing section. And after we process that information, we should be expecting a result. So let's run this code. Right now, we're not getting any output because our program has stopped at line number 4. The program is saying, I need a value for num1. I can't go on with 5, 6, 7, 8, 9, 10 until you give me my value. So num1, I'm going to set that to a value of 1. Now it stopped at num2. It's asking for value num2. Set that to 5. And then I'm going to put num3 as a value of 3. Now I have 1, value of 1 on num1, value of 5 for num2, and value of 3 for num3. And outputs 2, because if I were to add 1 and 5 together, I get 6. 6 floor divided by 3 will give me a value of 2. So in the inputs and my print statement, I didn't put any string values. That made our program look very ugly. But I just wanted to show you a bare bone example of how this algorithm is working line by line. And it is clear that we can separate it into multiple sections of input, processing, and output, which follow the IPO model. And for this video, we're going to stop here because we're going to go into IPO models later. In the rest of this worksheet, there are also programming exercises that I want you to try out, and those solutions will be held in another video. Anyways, thank you for watching and stay classy.